Principles of Bioproduct Separation, Module 9, Elution Chromatography, Segment 1, Absorbance. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. In this module, we will discuss about absorbance, yield and purity, discrete stage analysis, kinetic analysis, scaling up chromatography, and last but not least, exercises. Elution chromatography involves injecting a pulse of solute into one end of the column and then following the pulse with solvent. Eventually, the pulse comes out the other end of the column. The pulse will have entered as a narrow concentrated peak, but it will exit dispersed and diluted by the additional solvent. In elution chromatography, the goal is to purify the product even while it is diluted. Pulses of different solutes all leave the bed diluted, but they will leave at different times as shown in the left figure. Three solutes, shown as circles, squares, and triangles, are injected as a pulse into one end of the column. Solvent flows from left to right in the column, displacing the original contents. The solute shown as triangle is not absorbed much, so it is swept along quickly. The solute shown as circle is most strongly absorbed, so it is most retarded. Triangles reach the end of the column first and so are eluted first as shown in the figure. The squares and circles exit later. This difference in elution is the source of purification. At the end of this module, students will be assigned to do several exercises to determine sigma and yield, determine purity profile, determine number of stages, determine equilibrium constant, determine rate constant, and last but not least, determine elution time. Elution chromatography involves a pass of solutes swept through a packed column by excess solvent. The packed column contains solid adsorbents which retard specific solutes and hence effect the separations. The solid packings commonly used for elution chromatography can be categorized as large, medium, and small scale. For large scale, there are three types of chromatography, particularly adsorption, partition, and ion exchange. For adsorption, the typical adsorbent is inorganic materials like alumina and silica gel. For partition, the typical adsorbent is diatomaceous earth impregnated with organic liquids like propylene glycol has also been commonly used. For ion exchange, the typical adsorbent is polymer of sulfonated styrene. For moderate scale, there are two types of chromatography, particularly gel filtration and affinity. The best current methods for moderate scale chromatography uses gel as the solid phase. Two common types of gels are dextrans and polyacrylamide. The second method for moderate scale chromatography uses affinity resins as the solid phase. Resins enzymes are expensive but highly selective. For example, resins to which an antigen is attached will adsorb the antibody specific to that antigen. For small scale, there are two types of chromatography, particularly thin layer and paper. For TLC, a small pulse of solute is placed on a plate thinly coated with alumina or gel. The plate is dipped in solvent, removed, allowed to drain, and stained to show the position and intensity of the solute pulses. The intensity is often assumed to be a measure of concentration. For the next segment, we will discuss about yield and purity. Until then, I am Yusuf from Institut Teknologi Bandung.